In this talk, I want to present Goethean morphology as a remarkable case of non-contemporaneity of a thought to its time, that is, of the paradoxical temporality in which staying behind coincides with being ahead, to borrow a statement from Zizek about Schelling. More precisely, I would like to deliver a revitalized reading of Goethe that looks at the scientific body of his work, not so much as an example of pre-modern, anti-modern, or unconventional science, as it has often been portrayed due to Goethe's recurring attacks against the epitome of scientific materialism, namely Isaac Newton. Rather, I want to look at Goethe's scientific work as an innovative approach to nature that paved the way to a series of late modern epistemological and technological innovations currently cross-fertilizing each other, namely theoretical biology, artificial life, computational design thinking, and algorithmic architecture. To put it more clearly, if a large body of secondary literature presents Goethe's science as, and I quote biologist Daniel Christian Wahl, an alternative epistemology to that of conventional science, I think that we are rather dealing with a late modern epistemology, not so much opposed to conventional science, aka modern scientific materialism, than ahead of the determinist and mechanical procedures of modern science and its extension in the Enlightenment reason. So in my view, in his scientific work, Goethe is setting up a research program slowly coming to completion today, where computational and graphic devices are able to simulate, model, recreate, or even, as we shall see, extend the remarkable plasticity, self-organizational, and self-regenerative features displayed by nature's technique, or in Catherine Hale's terms, displayed by nature's non-conscious cognitive processes. So here, and for the rest of the talk, I understand computation in the sense of the term coined by contemporary computational design scholar Kostas Terzidis, that is going to be very useful for my talk, as you will see. That is, as a, I quote Terzidis, procedure of calculating something, determining something by logical or mathematical methods, as opposed to computerization as an act of mere processing and storing information in a computer system. So it means that computation doesn't necessarily involve a computer system, although the great processing capacities of the latter considerably facilitates the exercise of the former. Now, one of the reasons I think that Goethean morphology appeared inactual to its time is because it took more or less 1.5 centuries to find the adequate tools to properly launch his research program. However, the second half of the 20th century became the theater of a Goethe revival in natural and physical sciences, transitioning from causal and deterministic laws to nonlinear and fractal tools in mathematics and geometry. And those tools were eventually able to formally describe, but also to explore spatio-temporal evolutions of dynamical, irregular, discontinuous, complex, and even vague natural phenomena, such as plant growth, clouds transformation, or complex phenomena. And in the last 4 decades, the apparition of increasingly powerful computer systems, as well as a second generation of non-deterministic algorithm, defined by STS scholars as a new mode of algorithmic processing that learns from data without following explicit programming, considerably accelerated the path towards the completion of what I take to be Goethe's initial research program. So it is in this briefly depicted context, I think, that we should locate Goethe's debates with mechanism and scientific materialism. Indeed, by looking for a proper way, as opposed to a mere regulative way, to give access to the human understanding to nature's self-generating principles, Goethe is advocating for radicalization of the third critique as a way to overcome the nature-freedom gap culminating in Kant's first critique. Now, according to Goethe, the two key features securing the completion of this ambition are first, the anschauende Urteilskraft, that can be translated into English as judgment through intuitive perception, and the Urteil. The exercise of the former is aiming at building the latter, presented by Goethe as an immensely useful classificatory tool for the naturalist when he or she is confronted to the dazzling diversity of nature's production. And you see in the quotation that Goethe presents it as a general picture containing the forms of all animals as potential, which will guide us through to an orderly description of each animal. However, far from serving only identifying purposes, this tool, as we shall see, can also be generative and explorative. Now, the anschauende Urteilskraft has often been portrayed by Goethe's scholarship as the key component of his zarte Empirie, his delicate empiricism, aiming at, I quote Goethe, making itself utterly identical with the object, thereby becoming true theory. A lot has already been written on this topic, namely that zarte Empirie is a knowledge in tune with nature, or, I quote another Goethe scholar, Kostevroy, an intuitive alignment of thinking cognition with phenomena, building a new organ of intuitive apprehension. Although those claims are perfectly valid, they usually remain quite vague on the concrete ways in which this intuitive take on nature can be achieved, or this new organ of intuitive apprehension can be built. And this is why I want to insist here on the fact that the exercise of the anschauende Urteilskraft and the complex machine learning fashion in which it constructs the Urteil cannot be properly understood without focusing on the visual devices grounding it. Moreover, I claim that only the transformation of the physical eye of the naturalist into a kind of proto-machinic gaze can secure the access to the neutral, seemingly godlike point of view that Goethe is trying to provide the human understanding with in order to access nature's technique. And as you see in the quotation, this requires to seek out and examine what is in nature and not what pleases. Now, how does the disentanglement of the eye from its anthropocentric capture, focused on the fulfillment of the needs and desires of the human species, work? This point, I contend, can be made via fruitful cross-fertilization between contemporary innovations in the morphogenetic field and a careful analysis of Goethe's scientific writings and drawings. And so this will keep me busy with the rest of my talk. So in his studies for physiology of plants, Goethe formulates the main problem faced by naturalists interested in phenomena of growth and development in nature, that is, researchers trying to uncover the hidden laws driving the morphogenesis of natural products, in terms that are strictly reminiscent of contemporary issues faced by theoretical biologists, artificial life researchers, or even computational designers, as we shall see in a minute. I quote Goethe, "If I look at the created object, inquire into its creation, and follow this process back as far as I can, I will find a series of steps. Since these are not actually seen together before me, I must visualize them in my memory so that they form a certain ideal whole. The processes responsible for the growth and transformation of natural products are not given as such in the Empiria, or as Goethe would have it, the observer never sees the pure phenomenon with his own eyes." Similarly, prominent contemporary architect Jane Bury indicates that, I quote her, "Over the last half-century, architecture has been slowly adapting its representational practices from the conception of objects of sensory engagement to the construction of systems of formally described relationships. This shift from object description to definition of a dynamical space of design possibilities we call computational design. It is potentially invisible, seen only through its instances. It is these traces that are seen, not the model itself, which must be understood through more abstract, linguistic, mathematical, diagrammatic, and perhaps logical means. Note that the appeal to the architectural field is spot on in the context of my argument, since we assist today to bidirectional transfers from the computational modeling of morphogenesis in plant science to techniques in architectural designing. From what precedes, we can say that both Goethe and Bury are dealing with a similar problem, namely how to derive a generative model from its empirical data, or in contemporary machine learning terms, how to find the algorithm that produces a given output, how to find the open-ended rolling procedure driving the production and evolution of natural morphogenesis, following the partial traces it left in the empiria. To solve those problems, Goethe finds himself compelled to turn to a mode of visualization differing from immediate sensory perception, namely the above-mentioned Anschauen, the Urteilskraft. The exercise of this faculty is conditioned by the mediation of a series of devices that enables the researcher to visualize the play of forces at stake in phenomena of growth and evolution in nature. More precisely, the intuitive glance is performed by an expert eye that has been trained through intensive practice with drawings of natural products, such as plants, bone structures, or clouds, to, I quote Goethe, exclude the accidental, sets aside the impure, untangles the complicated, and even discovers the unknown. It is this kind of gaze that I call proto-machinic. The actual mode of operating of such a gaze remains somewhat dubious and confusing, if not combined with Goethe's claims scattered throughout his writings about the role played by visualization in his scientific work. Indeed, on several occasions, Goethe valorizes synoptic vision and drawing practices as particularly adequate tools for grasping the virtual domain actualized by manifest forms of a given natural realm. And so, in the context of this presentation, I'm going to focus mostly on drawings and more specifically on botanical drawings. And so after a careful look at Goethe's botanical sketches, it appears that those visualization techniques include the transformation of the common practice of botanical drawing, mostly playing an illustrative role in natural sciences, into a diagrammatic tool, allowing to map and explore the variations of the virtual field of polar forces driving morphological processes. Indeed, out of the hundreds of botanic drawings made by Goethe in the course of his life, only 20% of them displayed fixed, determined outlines with an insistence on singular details and colors, that is, on the materiality and actuality of the featured specimen. The remaining 80% display barely determined marks, quickly scribbled sketches made out of evasive dots, open-ended lines and spirals, alluding to nature's exuberant and never-ending productivity, but also proper diagrams, and even proto-simulations of structural morphogenetic transformations, paving the way to similar contemporary projects in the artificial life field using computer graphics and natural computing. Now, the diagrammatic aspect of Goethe's drawing seems to support an understanding of Goethean morphology as a science mainly interested in the exploration of abstract formal properties and their expressive power, where, I quote Costas Terzidis, expressiveness implies tendency, inclination, propensity, disposition, or proclivity, rather than statism, preformation, or definiteness. Indeed, by disentangling morphology from its ancillary functions with other sciences such as biology, physics, or chemistry, in order to single it out as a new science, and I quote Goethe, viewed foremost as a theory in and of itself, Goethe's approach produced a shift of perspective in natural sciences, turning away the then usual attention of the observer for the contingent material actualization of natural products, to look instead at natural morphologies as various systems of articulation of dynamic and abstract relationships between virtual polar forces. Goethe's morphology thus display a fundamental transition from a Kantian-like representational approach to nature to a generative one, not only able to grasp and recreate nature's technique, but also to extend it. Indeed, as Goethe famously notes in his Italian journey, I quote Goethe, with this model, and he speaks about the Urpflanzer here, with this model and the key to it, one will be able to invent plants without limit to control. That is to say, plants which, even if they do not actually exist, nevertheless might exist, and which are not merely picturesque or poetic visions and illusions, but have an inner truth and logic. So following Goethe, the Urtype is the key feature of his morphological method, both enabling to generate existing morphologies and to explore new ones by following nature's logic, thus extending the scope of the actual. In this context, I would like to suggest to look at the Urtypes as computational matrices capable of generating the structures of actual and virtual entities. And here I draw on Terzides' understanding of the properties of computation that I mentioned earlier, where I quote Terzides, computation is about the exploration of indeterminate, vague, unclear, and often ill-defined processes. Because of its exploratory nature, computation aims at emulating or extending the human intellect. Indeed, despite a long-lasting preconception insisting on Goethe's aversion for any kind of computational tool, it should be noted that in the paragraph 102 of the Metamorphosis of Plants, Goethe compares the Urtype with an algebraic formula. He says that the observer should feel comfortable working with the principle established above, expansion and contraction, compaction and anastomosis, as he will with algebraic formulas. And the comparison is extended in other parts of his work. So he also said in other fragments that the Urtype shows the general formula, so to speak, that overarches an array of individual arithmetic sums. And he also says, from the mathematician, we must learn the meticulous care required to connect things in unbroken succession, or rather, to derive things step by step. So I argue that emphasizing the algebraic dimension of the Goethean Urtype, as well as Goethe's interest for the abstracting properties of certain computational tools, can help us to sketch a path from Goethean morphology to contemporary computational techniques of pattern generation, recognition, and exploration. In fact, although Goethe refuses to apply computational tools directly to morphogenesis, he nonetheless seems to advocate for the transplantation of typical algebraic properties, such as condensation and derivation, into his morphological method. As a matter of fact, an algebraic formula is a formal reduction condensing a specific type of relation from which one can deduce one or several variables expressing that relation, a mode of operating that is reminiscent of the Goethean Urtype. Moreover, following Hans Jakob, at Goethe's time, algebraic analysis was mainly described as a process of, I quote, understanding certain relations from their own presuppositions in a purely conceptual way. To understand given relations in and of themselves, one must generalize them and see them abstractly. Recurring to the theory of art, we can speak of an act of alienation. In fact, since this time, the analogy between art and mathematics has held a special attraction for many pure mathematicians. A definition of mathematics as a theory of forms, Formenlehre, became common at this time. We can therefore make the hypothesis that algebraic analysis was attractive to Goethe, trying to single out morphology as an autonomous science because it provided an elaborated method of departing from human perception to reach another realm where forms are understood as systems of abstract relationships rather than contingent material entities able to evolve according to open transformation rules. Hence, I make the suggestion that what Kostas Terzidis writes in the context of contemporary formal exploration in architecture, or what he calls algorithmic form, can apply to Goethe's notion of form. Form is not always conceived literally as made out of matter. In fact, form is rather an abstract entity that possesses certain geometric characteristics. The attachment of material qualities constrains the behavior of form. In contrast, the lack of materiality liberates form from its constraints and introduces behaviors closer to intuition rather than perception. Significantly, this approach, favoring formal, relational, and logical properties over contingent material ones, formed the basis for the emergence of a new research field in the late 80s called artificial life. The main characteristic of this fast-developing area of research is the fundamental transition from the traditional study of life as we know it, or biology as a terrestrial fact, to life as it might be. As Christopher Langton, a pioneer in this field, puts it in terms that are quite reminiscent of the Italian journey, and I quote Christopher Langton, the set of biological entities provided to us by nature, broad and diverse as it is dominated by accident and historical contingency. We trust implicitly that there were lawful regularities at work in the determination of this set, but it is unlikely that we will discover many of these regularities by restricting ourselves only to the set of biological entities that nature actually provided us with. Rather, such regularities will be found only by exploring the much larger set of possible biological entities. Moreover, in its strong version, artificial life goes as far as to make the claim that life is a theoretical program, mostly resting on logical and organizational properties rather than on specific material components, and that it can be instantiated in many different kinds of medium, technological or biological. In my understanding of Goethe's scientific writings, I see the research program that he is trying to establish as precisely such an attempt to produce an extended view on nature. This program, I contend, requires the development of technological means that are disentangled from their dominant anthropic capture in order to get closer to the core of nature's processes and to cooperate with them. In so doing, they render the borders between technique and nature increasingly blurred. And that's how I understand what Sartre empiri means. So to sum up and to conclude, I propose to read Goethean morphology as an original practice of reduction, departing from the phenomenological realm to intuit nature's dynamical space of botanical possibilities in the present case that I have been presenting, and to explore its virtual realm. And that's a program who found fruitful contemporary extension in the artificial life field, for instance, the project of Przemysław Kozinkiewicz and Aristide Lindenmayer of building a virtual laboratory of computational plant illustrates. In this context, the main remit of reduction is not to simplify complexity, as is usually the case in modern natural sciences, but rather to let visually emerge the autonomous processes that superintend the generation of complexity itself. In short, what Goethe is trying to achieve is to comprehend the logic of nature from within, instead of merely trying to represent or mimic it. It is this very methodological gesture initiated by Goethe in the natural sciences that open up the way to contemporary practices of definition and exploration of the dynamical space of virtual possibilities in a given domain via computation and computer graphics. And I'll stop here.